All right, so notice and wonder. So on one side, you're gonna write notice. One side, you're gonna write wonder. Okay, I'm gonna give y'all about a minute. I want y'all to look through all of the details of this. Look at everything it gives you. Look at the name of the X and Y axis. Look at what the data looks like. What is it doing? Note, make observations about all the different points of it, and then any questions that you have. I'm going to give you a little over a minute, and when the timer goes off, we will discuss it. Ready, go. It'll be a little easier to read.
Anybody else do that? What? Noise?
The rain.
Yes, it's going.
Just turn it off.
I'll have about 10 seconds left, and then we're going to talk about it.
3, 2, 1, ding. 1.
This is not making a sound. Interesting. Okay, now I'm going to give you 30 seconds. I want you to share with someone sitting around you what you noticed, what you wondered. Ready, go.
There isn't a line.
I just said,
Like,
I just put wire.
there's only one dot on the line.
And y'all are really good, because I just said very sky.
I just don't, why did they make this?
Wow. Why make it?
All right, let's talk about it. So let's look at some of the stuff that you noticed. Kobe, what did you notice?
There's only one dot on the line.
Okay, so there's only one dot touching the line. Wait. Hey, listen, if I'm writing it up here and you don't have that, you also need to be writing it in your book.
There's
So,
actually 3 dots, no, 4 dots touching the line.
Only
If you
one
look
on the
closely.
line.
Okay, well, he noticed that.
one dot all the way on the line. We'll say that.
Okay.
I would say, actually, no. He.
All right, Kyle,
There is no Y intercept.
no Y intercept. Good.
I got that from me.
Yeah.
All right, what else do y'all notice? Ava?
The dots do not all form a line.
Okay, the dots do not all fall on the line. All right, Luke?
They're increasing.
They're increasing. Good. Jamarius? Okay, so it's increasing, but it's not increasing at a constant rate. Okay, so I'll put increasing, but not at a constant rate. So what I mean by that is if it was increasing at a constant rate, all the dots would form a perfect line. Okay, because they would all have the same slope, but these don't. Okay, so they're more random. So they are all increasing for the most part. The general trend of the whole data is increasing, but not at a constant rate anymore. Kobe.
It's measuring like how loud a certain number of people are.
It's measuring how loud a certain number of people are. Okay, so what can you interpret from this data then?
what is it?
The more people, the louder.
The more people, the louder it is. Good. More people equals more noise. Does that make sense? Like for what we know about large groups of people? Yeah. Good. This is my best notice so far. Awesome.
My goodness.
Okay, so very good. So we notice they're not all on line, they're all increasing, but not at a constant rate. The more people we have, the more noise. Anything else before we move on? Okay, the one thing that I noticed is that they give us this equation up here. Okay,
Oh, shoot.
I know it's kind of hard. It's kind of easy to miss. It's really tiny. So what do we think this equation is for?
Why?
Okay, but look at the format of it.
Always, so, intersection.
Slope-intercept form, and we know slope-intercept forms say what? A line. So what do you think this equation is for?
This one.
That's probably for this line over here.
Oh, that's crazy.
All right, so the name of this equation, we kind of wrote it in our goals. That's a linear model, aka just an equation, but they're going to call it a linear model when they're referring to an equation. Okay? And what do we notice about this line? What is it doing?
Increasing.
It is increasing. We got that.
Blue.
Huh?
It's also blue.
Is it? What is it doing with our data? Okay, it's separating it. So it's not necessarily separating it because we're not putting them in two groups, but you're on the right track. Just describe what's happening with this line. It is increasing.
The more people you like it, and the more people there are.
Yeah. I'm just saying, like, physically, what is this line doing?
It's that point.
Huh?
It's that point.
It doesn't have a y-intercept, but this line is going through the center of the data, right? Okay, so write that down. Line is going through center of data. So we kind of talked about that in that little worksheet. Okay, that line is, it's not really necessarily on all the points. We talked about that. It's going through the center of all the data points. Okay, so we're going to talk about why that is as we move on. Okay, anything else we notice? All right, what are some questions that we have about this graph? Luke,
Why the line is blue and none of the other parts of the graph is blue?
okay. What else? What else do we notice, Ava?
Why are all the dots not on the line?
Okay, why are dots not on the line? Okay, Luke,
There isn't a starting point on the line, so I'm wondering why there isn't.
so why no starting point?
I
Ka?
feel like,
Oh, sorry.
I feel like there is a starting point because that's where the line starts with the dot, like the first dot.
So like, you think, but, I mean, yeah, probably so, but do you think we just started out with 60,000 people in this building? I mean, there may be more to it. This just may be what they chose to graph out of it for this particular set of data.
There's no way you would start off with immediately 60,000 people.
Hey, where you walk in the gym, you're like, boom, 60 people.
Like, you could just take the roof off.
Yeah.
People come through. It's a math thing.
Let them go shut up.
All right.
67 kids.
Next, Kai.
Why does it drop off like at the very beginning? Right there.
Okay, well, okay, why does it drop off?
Yeah.
Okay, well, let's think of what we're talking about. So we're talking about 65,000 people right here. So what could cause them, there is a Chromebook back there. All right, listen, there's 65,000 people right here. So what could cause the noise level to not be as high as other spots?
They shut up.
They could be being quieter. Okay, so that may be why it dropped there. Anything else? What else are we wondering about? Kobe.
What your question is.
Why do they want to make the ground in the first place?
Okay, so why do we do it? Okay, what else? Look,
What do you think?
I don't have an opinion about, I don't have any questions about it.
Oh yeah, I forget you're the patient.
All right, so we're gonna go on through this lesson and we'll probably be able to answer some of these questions as we go on. But also keep in mind all these observations we make because those are gonna be important as we move forward as well. All right, so next part, we're gonna watch a quick little video and record the weight for the number of oranges in a box, okay? It's literally a video of someone putting oranges into a box and we're going to write down the weight. So even if you can't necessarily see the weight, I will tell you what the values are so we are all on the same page, okay? So it's probably not the cinematic masterpiece you think it's gonna be. Yes, we will.
Wait,
I have
so,
really high expectations for this.
so is the box weight gonna be in there, or are we gonna have to subtract the weight of the box?
We're gonna watch the video and then we'll talk about it.
Whoa.
It didn't go up. You should name all the oranges. Bob, Sally, Craig.
All of them are named Bob.
Like Chris Brown 2001.
Chris Reed.
No, Chris Brown. I used
Wait, they're already in there.
Well, it's just like the clip of the, it's just like the cover photo of it. All right, here we go. We got 3 oranges in there. This is the weight. You can see it down here at the bottom of the screen is the scale. This is in kilograms. Okay, so real quick, we're looking at this table in your book. All right, so our first column is the number of oranges. That's going to be our X value. That's going to be the independent variable, the one that we have control over. Okay, so we can control how many oranges we are adding to the box. Okay, then depending on how many oranges are in our box is going to affect the weight, which will be our Y values. Okay. So we're about to take all this information, we're going to graph it, we're going to come up with all of the stuff. So let's gather our data. So right here, we have 3 oranges in the box and the weight is 1. I know you can't really see the decimal, it's extremely tiny, but it's 1.027. So in your table, 1.027. Okay, that's for 3 oranges. All right, let's make some observations about our oranges really quickly.
Oh, there's 2 big ones and 1 small one.
There's 2 big ones and 1 small one, okay? So we know that, do you think all of these oranges weigh the exact same amount? No, so are they gonna increase, or wait, sorry. What do you think is gonna happen the more oranges we add into the box? We think the weight's gonna increase?
But it won't increase by 1.07.
Okay, listen, Luke just said it probably won't increase by, he said a specific amount each time. Why do we not think it's going to increase at the same exact rate every time?
Because you always add the.
Okay, they're not this, the oranges don't all weigh the same, right? Okay. Okay, here we go. Here's the next orange. And number 4. Okay. So now it's 1.162. 1.162. All right, 5th orange. 1.502.
That is a big boy.
I'm starting to see a pattern.
No, he wants it.
1.617.
Every orange that he adds puts another orange in back.
I think you're onto something.
A mess.
All right, here we go. 7th orange. 1.7. Look, it dropped back down. It's 1.761.
What was the orange like burn out?
All right, here we go. We have 8. 2.115.
That's another thick boy.
9th orange is 2.233.
We don't get the free right here.
All right, last orange.
Thick boy. Oh, when it died.
2.569. Gosh. Oh my gosh. All right, so there are our oranges and their weights. Okay, so was our assumption right? The more oranges we added, the higher the weight got? Yes. Okay, now what we're going to do is we are going to create a scatter plot of the data. So underline create a scatter plot. All right, I'm going to show y'all how to do this using technology, and you're going to realize this is so easy to do it on technology. So go ahead and get your Chromebooks open and go to, open up Google Chrome and go to Desmos calculator.
I might need to actually start it right now.
I don't have my Chromebook on.
That's not good.
You never had.
I don't think you ever did.
I've never seen you.
No, I'm always in that. See, I thought you were missing my call the other day.
All right, everyone at home, y'all need to split your screen, half Google Classroom. I'm sorry, half Desmos and half Zoom, so you can see what you're supposed to be doing.
Can you give me the other?
There's the most.
Maybe he's in a bad mood today.
You gotta add it to.
Dude, Laney?
Maybe she just wants to be left alone.
You know, I wish.
He's mad that he's not on TV anymore.
I am
Furious.
I am so happy. I'm finally on TV.
All right,
Don't do
so
it.
we have
I don't
Desmos.
like TV.
Now we're gonna take all of that data we just collected and we are going to put it in Desmos. So I'm gonna show y'all how to do that. So give me a thumbs up if we're all on this screen.
Yeah, that's not one.
I'm not even signed in yet.
Huh?
I'm not signed in
I
yet.
need to do better.
All right, give me a thumbs up if you are there so I know when I can start.
Where is this one?
You have to go to Google and search. Look what I searched, desmos.com/calculator. Yep.
All of that was the noise.
I just stopped at Desmond's.
All of it.
Yeah.
I put in this. See, I pay attention.
I was not even gonna start.
All right, people on Zoom, are y'all there?
Ouch.
Hey, look. It's a
Yes, ma'am.
Good deal. Okay, I'm gonna go ahead and get started. I'm gonna write down these steps so you can put them down in your book here in a second. Okay, so I'm gonna show y'all how to put a table into Desmos. So right here above, like right here where you're typing, where it says 1 in this little box, right above it, mine's kind of off my screen a little bit, but it's has a little plus sign. Click on that plus sign and you get this drop down menu. And you're going to click on the one that says table. Okay, now before y'all get started, I want y'all to look at this table. They labeled theirs a little different than mine. They put X1 and Y1, okay? Because on Desmos, there's an option where you can make multiple tables and it will graph multiple things. So like if, don't do this, but if I click down here where it says 2, on this 2 column, and I added another table, now what does it say? X2 and Y2. Okay, that way if we wanted to pull data from a specific table, we had to specify that we want it from table 1 or table 2. Okay, and that'll be important here in a second. Okay, so I'm going to just exit off that second one. All right, and what y'all are going to do is y'all are going to start typing in your data from your table into this. Now remember back in unit 1, the data entry, since that's the only thing y'all are contributing to it, you have to type in your data exactly correct, because one digit off can mess up the whole problem. So take a second, take your time, and write down your data points from the table that we just did.
This is gonna be fun.
It is so
This would
fun.
be a good for yoga student.
Yes,
Why do you have 3, 4, 5, 6, 7, 8, 9, 10?
because that's what my table is.
Well, you guys question everything.
Why do you have to question the question? Wait, so it's steadily rising. Ah,
And a bow, and a bow.
Get your data tapped in.
I did it. Like, maybe you can't do it in the change or something.
Oh, it's making it already.
Yeah.
So cool.
Mr. Ruby,
Yes, ma'am.
so, not, like, I don't know if I do it back, because, well, eventually,
Mine's probably just more zoomed out. Look,
because you have like, oh, right there, yeah. I was confused, because I thought it was.
yeah, I was just zoomed in and out.
Mr. B,
Yes, sir.
have you ever eaten a Jack in the Box?
I have not.
Dude, they have the best tacos in the world.
Oh, yeah.
I
Tacos?
think they're burgers, though. Their
I've
burgers
seen
are
one of
awesome.
those in like 4
What?
times.
It's like
Their
a burger,
burgers are
chocolate you get, but with butter.
All right. If you're still typing your data, that's fine, but go back to your book and I want you to write these steps. Right here where it says create a scatter plot. So when you're doing your homework or anything, you can go back and remember how you created that table.
Okay. Yes, we do. When I went and got tacos from Jack in the Box,
Mm-hmm.
went to the bank to get my grandpa some money. That was in St. Louis. And we were talking, and I looked at the window, and a freaking drive-by happened.
Really?
Dead serious. And then right, someone died too. Yeah.
All right. Write those steps down so you remember how to do them.
Click plus. Click table. All in that order. Oh, wait. Go to Desmond. You didn't know that.
Whoa. You can zoom out really far. Yeah. Oh, and now it just looks like one small dot compared to 200,000.
Kyle, do you have those steps written down?
Yeah. I mean,
You wrote them down?
we have to write that down?
Yeah, so that you remember how to do it.
No.
You don't have to write those down.
Where do I write them?
On your
In your book by number 2.
Oh, I wrote it by the date. I wrote it exactly where you wrote it.
Okay, so now we've got the table in there. We created a scatter plot. Let's make some observations about our dots now that we have them graphed. Okay, what do you notice about this graph?
It steadily goes up.
It steadily goes up. Okay, yeah. Is it?
They're not all in a straight line.
It's not in a straight line. Why did we kind of discuss this already, but why are the dots not in a perfect straight line?
Because not all the oranges weigh the exact
Not all the
same.
oranges weighed the same amount. Okay, what else do we notice? Anything else?
He started off with 3 oranges.
He started off with 3, so that's why it didn't really start at the origin. We didn't start off with all of that. We just started out with the 3 oranges. So now, next, number 3, it wants us to draw a line through the data that fits the data well. Underline fits the data well. Okay, so when we're talking about a line that fits the data well, because our data is not in a perfectly straight line, okay, it means it's unpredictable because it's not increasing at the same rate. So we need a line that fits the data as best as we possibly can so that we can make predictions and estimates about if we had more oranges and their weight, or in real life situations, whatever we're talking about. So when it's talking about a line that fits the data well, we're talking about the line of best fit. Okay? So that's what it's wanting us to find here, the line of best fit. And I'm going to show you how to do that on Desmos, okay? If y'all remember all the steps that we had to do on the worksheet last week, we had to find the slope, we had to find the y-intercept, and then we had to create our equation, right? Okay, I'll show you a much easier way. Now, you're going to go back to Desmos, and you're going to click down here under your table where it says, it's kind of hard to see on mine, but the tab that says 2. You typed in the one that said 1, now you're clicking in the one that says 2. Y'all pay attention. This is a lot less steps than what we did last time. Okay, so if we want a line, we have to remember the equation for a line, y equals mx plus b, right? Okay, but we can't just type in y equals mx plus b because watch what happens. Okay, nothing. Okay, but we have to be specific about what x and what y we're pulling our data from. So if we want to be specific, we can't just put y. We're trying to pull data from what? The table. So we need to specify and put y1. Okay, so going back down here, we need to put y1. So just type a 1 after it. Okay, and this is a line that fits the data well. It's not perfect for it. It's not going to be exactly equal. So instead of putting an equal sign, we're going to put this little squiggly. So everyone hold up your finger like this. Point to the number 1 on your keyboard. And then right beside the 1, there's a little squiggle. So you hit shift and then you hit that little key. Okay, and you get a little squiggle line. Okay, so that's like the approximate. What? Oh, all right. Now the next part of the equation is mx plus b. Okay, so we put our m. And then we have x, but we can't just put any x. We want to pull the data from our table. So we need to put x1. All right, it started to form a line, but we're not finished yet. We still need to put plus b. Now, look what happened to our line. What is it doing?
It made a line.
It's pretty much going through all of our data now, isn't it? Okay, so going back to our paper, we're going to write down that little equation so you remember it, okay? So it's y1 squiggle mx1 plus b.
No, I did it. No problem. I don't just whistle.
All right, and I like to make little notes for myself because if I look at that in a couple weeks, I'm gonna be like, what the heck is this? That's what we type into Desmos for the line of best fit. It does, it looks like the slope intercept form. Okay, so now I want the actual equation. I want the equation that will go for that exact line. So I need the exact values. Okay, so I'm gonna put that in y equals mx format. Okay, so we're gonna put that in y equals mx plus b format. So let's go back to Desmos. Okay, and right below it, I'm gonna zoom in.
What is it, what did you write on there? Why was it?
Yeah. Okay, so then right underneath where we type that, it gives us all of these data points. We've got our statistics. We haven't learned about R squared and R, so just ignore those. We haven't learned about residuals, so just ignore those. And then we've got our parameters. Look what they're labeled, M and B. Do we know what those mean? What does M mean? It's your slope. What is B? Y-intercept, okay? So now if you did not type in your data exactly right, your digits may be slightly off, okay? But what is our slope for this line? Let's go to 2 decimal places. 0.22. All right, what is my y-intercept?
0.35.
0.35.
How did you write it?
I'm about to go back. All right, so this is my equation for my line. I have it in slope intercept form. So I have y equals my slope and plus my slope X plus my y-intercept. All right, and what is this equation for?
Line of best fit.
My line of best fit. Okay, so when we graph data that's scattered like that, it's not a perfect line. We need a line that best summarizes it, that goes through it the best we possibly can. Okay, so that's the line of best fit. So this is the equation for the line that fits the data the best. Okay, moving on. Number 4. It says estimate a value for the slope of the line that you drew. It says estimate because it wanted you to draw it out over here. But since we use technology, we know what the slope is that fits the data the best. What is it? What is my slope? 0.22. Okay, that is my slope. Okay, now the second part of the question, what does that value of the slope represent? Okay, well, in order to answer that, we have to know what slope is. The slope tells you how your graph increases or decreases. So what is my graph doing? It's increasing by how much? 0.22. So anytime you're describing the slope, you always start by describing the y-axis because we know that the slope is the change of y over the change of x. Okay, so we said our graph is increasing, but specifically we have to describe our y value. So what is our y value talking about?
Weight.
Okay, so we can put the weight is increasing. How much is it increasing by?
0.22.
0.22 kilograms. Okay, so the weight is increasing. Oops, I forgot by 0.22 kilograms for every 1 orange. I'm sorry, by about. Okay, it's not exact or it would have formed a perfect line. So the weight is increasing by about 0.22 kilograms for every 1 orange. That is what our slope means. Now looking back at our goal, there was one that said interpret the slope and the y-intercept. That's what we just did right here. We interpreted the slope. Okay, so we can see that we put our y value first. The weight is our y value, and the number of oranges is our x. Okay, now number 5 and 6 are kind of the big focal point, and after we finish through 9, we'll take a quick break. So stay with me. Okay, so it says estimate, highlight, underline, put a circle around, estimate the weight of a box containing 11 oranges. Okay, so when it asks you about estimating a specific value from the table or from the data, that's a key word right there that we use the line of best fit. Okay, because our data, we're looking at it, it doesn't have an 11th orange on there. Okay, so if we wanted to make an estimate or an educated guess about it, the only thing we have to guess by is this line. Okay, that doesn't mean it's going to be the actual value of 11 oranges, but it's going to be as close as we can possibly get. Okay, so we're going to use that equation to figure it out. So anytime you see estimate or predict, we use our line of best fit. So let's write out that equation. Y equals 0.22x plus 0.35. Okay, because that line is going to go on forever and ever, and so we can make predictions about the weights that we don't have. Okay, so we know that. So we want to know the weight of the box. So that's our Y value. And we have 11 oranges. Where in our, what variable talks about the number of oranges we have? X. So they gave us the X value. X equals what? X equals 11. So if I'm trying to find Y and I know X, I have an equation, I have a variable, what do?
Plug it in.
Plug it in. So I have Y equals 0.22, but instead of X, I'm gonna put 11 in parentheses plus 0.35. Okay, I'm solving for Y. So since I already have my variables on one side and my numbers on the other, I can just simplify. So what, I have multiplying and addition, what do I do first? I do multiplication, so I have 0.22 times 11, which is 2.42. All right, then I have to add 0.35, and I get 2.77. And since we're talking about the weight of the box, it's 2.77 kilograms. So what does this value mean? That's the weight of the box of everything with 11 oranges in it. Okay, now we started out, we only had 10 oranges. It wanted us to estimate. We don't have 11 oranges with us. We only have 10. So this is our educated guess. Do you think this estimate will be close to the actual value? This isn't saying, okay, if we have 11 oranges, it's definitely going to be 2.77 kilograms. We know that's not exactly right because some oranges are big, some oranges are small. So it's not, it's just an estimate. But do we think that will be pretty close to the actual value?
I don't,
Yes.
I don't know, I feel like it will be that.
I feel like it would definitely be good.
Definitely pretty good. I think it'll be, I think since we did use our line of best fit and we're only increasing by 1 orange, we can't get it that drastically wrong because we're only adding 1 orange. Okay, there's not that much room for error with 1 orange. So will this estimate be close? Yes. We are only adding 1 orange, so it can't be too far from actual value. All right, if you get that description finished, look at number 6 and see if you can figure out how to start that problem. It's very similar to number 5. Okay, number 6, it says that keyword estimate. What are we estimating? The weight of the box again. So that's our Y value. Containing what? We're containing 50 oranges this time. Okay, so because we're estimating, what do we use to make estimates and predictions? We use the line of best fit. So let's write that equation down again for our line of best fit. All right, and this time we have 50 oranges. So what variable did they tell us this time? X. Yep. So I have an equation. I have a variable. What am I going to do? Plug it in. So I have Y equals 0.22, but instead of X, I'm going to put 50 plus 0.35. Now we're gonna solve it, so let's simplify. What do I do first, multiplication or addition? Multiplication, and I get 11.
Yeah.
All right. I have 11 plus 0.35, and that is 11.35. Okay, this time, now remember, in our possession, we only have those 10 oranges. We do not have 50 oranges to check. Okay, this is just an estimate based off of all that we know, and all that we know is that line of best fit. Okay, so now that we're going from 10 to 50 oranges, do you think this estimate will be close to the actual value?
I said no because we added a lot more oranges, so it wasn't drastically wrong.
Yeah, because I mean, if we're just guessing that all of them are really big oranges or all of them are really small oranges, we don't know. So there's a lot more room for error, right? So we can say probably not, because there is more room for error. But based on what we know, that is the most accurate answer we can get, okay? But just because that's the most accurate answer we can get does not mean it's close to the actual value, okay? But based on what we know, that's as close as we can get.
Okay, this is kind of like a question about estimating.
Okay,
So like in elementary, they told us like, when you're estimating, just like think, like don't do any math, just like think.
mm-hmm.
So why are we doing that with estimating?
Because you know more to make a better guess.
Okay. Cause I was very confused, I was like, isn't estimating just like, you just.
Most of the time estimating was just like for like rounding numbers. So like you're just getting as close to it as you can. And that's kind of what we're doing here too. You're getting as close to it as you can, but you know more information now.
I was told that estimate is like, do what you can with what you got.
And that's what we did. We did what we can with what we got. All right, number 7, we're going to estimate the coordinates of the vertical intercept. I don't know why they call it a vertical intercept, but that's just the y-intercept. It is vertical, but every other book I've ever looked in has called it the y-intercept. All right, so estimate the coordinates for the vertical intercept of the line you drew. Okay, we don't have to estimate it because we use technology. What is our y-intercept? 0.35. Okay, we can just find it in our line of best fit equation. Okay, so there's our value. It's probably an estimate because once again, it is the line that best fits it. It's not the exact. It says, what might the y coordinate for this point represent? So this is a same type of question as like what we did for the slope. We're now interpreting the y-intercept. So in order to interpret the y-intercept, we need to go back to the graph and see what we are talking about. So let's go back to our graph and let's look at our y-intercept. We know it's the point that it crosses through the y-axis. So there it is right there. We can see that our y value is 0.35, like we said, right? Okay. Now, what are we talking about in our y values? What are our y values talk about?
The number of oranges,
The y values do?
I mean, the weight.
The weight. Okay, so what is the weight?
0.35.
Okay, and then what is our x values talking about? Oranges. How many oranges do I have?
0.
Okay, so if I have 0 oranges in the box, how does it weigh 0.35? Okay, so what does the y-intercept represent? The weight of the box. It's the weight of the box with no oranges in it. Okay, so what does the y-intercept represent? The weight of the box with 0 oranges in it. All right, now last two questions. This one you will use the graph to answer. So make you a little note, 8 and 9. Use the graph to answer. Okay. It says which points are best fit by your linear model. Remember, linear model is just that equation for our line. Okay, so let's go back to our graph. So each one of these dots, remember that's the dot that represents 3 oranges, 4, 5, 6, 7, 8, 9, and 10 oranges. Okay. Trying to get them all in the.
One dot is not.
Okay, looking at this, looking at the model, need everyone's eyes up here because I'm hoping y'all are looking at your graphs, but who knows? Which one of the points is the best fit point for this equation, for this line? Okay, so we said 4. Okay, yeah, it does say point or points. Okay, so y'all said 4 and 6. So why 4 and 6? Ava?
6 like is really like it's more than it's like falling on the line more than the other.
Okay, so it's the closest one to the line. Okay, good. So for those of y'all that are at home, Ava said 6, and I know Colby and a few other people said 4 as well, because those are the points that are on the most on the line or touching the line. Okay, so for number 8, we're gonna say 4 and 6. And then it asks, how did you decide? They're the closest to the line of best fit. Okay, so those are going to be the points that are close. Like if we use the line of best fit, that line of best fit is going to get us the closest to the actual value, to the points that are touching it. All right, which points are fit the least well by your linear model? Okay, looking back here, which ones look like they are the least well fit?
7.
We have 5, I heard 7. Do y'all agree with that? Okay, why 5 and 7? They're the farthest off the line. So how do you know? They're the farthest from the line of best fit. All right, we're going to take a quick break and then we'll come back to our lesson in just a second. Okay, so 4.3, we have a scatter plot that shows the sale prices of several food items, and that's our Y value. So underline sale price, that's our Y value. All right, and then we've got the cost of ingredients used to produce those items, and that's our X value. And you can see those represented in our graph down here. We have ingredients cost, that's our X. And we have the sale price, that's our Y. Okay. Because it's several food items, we can see that it's all scattered around. It's not constant, increasing at a constant rate. It's just like all over the place. Also, as well as those X and Y values, we have a line that models the data. The line is represented by this equation. Okay, so put a box around it. If they give you an equation for this, for the data, you need to pay attention to it. Okay, so that is our equation for our what? The line of best fit. So go ahead and label that. All right, and what do we use the line of best fit to do?
It's still like estimate.
Estimate and make predictions. Okay, so let's look at question number 1. It says, what is the predicted, highlight predicted sale price? So what are we trying to find? Sell price. So where on our graph does it talk about sell price?
Wow.
The Y. So we're trying to find the Y value of an item that has ingredients that cost $1.50. Where do we talk about ingredients cost? X. Okay, so because they're wanting us to make a prediction, what do we use to make predictions? Because if we were to look on here, because we can see $1.50 in our graph, it's right there. But if I look at that dot, I can't see exactly what that value is. Okay, so to get as close to that value as we can, and it wants us to make a prediction, what do we use? What do we use to make predictions and estimates? The line of best fit. Did they give that to us? Yes, so let's write down what we know. We know Y equals 3.48x plus 0.76. Okay, we're trying to find our Y, so we need to know our X. Says the ingredients cost $1.50. So we also know that what? X is $1.50. All right, I have an equation. I have a variable. What do? Plug it in. So I have Y equals 3.48, but instead of X, I'm going to put 1.50 plus 0.76. Okay, we are solving for Y. So my variable's already on one side, so I can just simplify it. What do I do first, multiplication or addition? Multiplication. So I have 3.48 times 150, and I get 5.22. So I have Y equals $5.22 plus 0.76. So we have $5.98. All right. Is this exactly what the sell price will be if the ingredients cost $1.50? No, this is our predicted value based off of the line of best fit. Okay, so that's as close as we can get with what we know. All right, number 2, it says, what is the predicted ingredient cost? Where in our graph do we talk about the ingredient cost? X. So what are we trying to find this time? X. So if we are trying to find X, we have to know what the Y value is of an item that has a sell price of $7. Where in the graph does it talk about sell price? The Y value. Okay, so if we're going to make a prediction, what do we use? The line of best fit. So I'm going to write down what I know, which is that equation. All right, what else did this problem tell us? We said we're trying to solve for X, which is the ingredient cost. So what do we have to know? Nope, we have to know what Y equals in order to solve for it. Did they tell us that? $7. We have an equation. We have a variable. What do? Plug it in. Now be careful this time because it tells you this time Y equals 7. So that goes over here. So now it's 7 equals 3.48 X plus 0.76. So this one's going to be a little different. So we're solving for X. So if we're solving for X, we start with a term that is, how do I get rid of a positive 0.76? Minus 0.76. If I do it to one side, gotta do it to the other side. What happens to my 0.76? Cancels out. I have 7 minus 0.76. I get 6.24 equals 3.48x. I'm almost finished, but I still got to get that x by itself. So that's 3.48 times x. So how do I get rid of the 3.48? I divide it by 3.48. If I do it to one side,
Gotta do it.
gotta do it to the other side. All right, what happens to my 3.48? They cancel out. What do I have to do over here? I have to divide. So I have 6.24 divided by 3.48, and I get this long decimal. Now, in order to know when to stop our decimal, we're talking about money. So if we're talking about money, how many decimals do I go to?
The two.
2. Okay, so what is my final answer? 1.79. X equals $1.79. So if I sold something for $7, how much did it cost to get the ingredients? $1.79.
Why don't we, like last year when we had like the days when we would like get us food and stuff, the food trucks, why don't we do that anymore?
Probably because of the pandemic.
Who cares? We've all had it.
Your thing
I think we've
was
all had it.
hurtful.
Has anyone in here not had it?
I haven't.
Really?
Okay, number 3. It says, what is the slope of the linear model? Okay, underline slope. Okay. What is the slope of this linear model? Where can we find the slope at?
And
It's in the equation. So I need to look up at the equation. What is my slope? 3.48. Okay, yes, we know how to point it out in an equation, but it wants us to go a step further. What does this mean in the situation? What increases by 3.48?
It's like about how many ingredients?
Okay, you're on the right track. Remember, it's the change of y over the change of x. So we start out with the y. So we say the sell price. It's increasing. Why is it increasing? Or how do we know it's increasing?
Because the line is going up.
It's going up and it's positive. So the sale price is increasing by how much?
3.48.
By about $3.48 for every one what? For every one ingredient cost. Out. Okay, while y'all writing that down, let's read number 4. It says, what is the y-intercept of the linear model? What does it mean in this situation? Okay, so the y-intercept is, we have to go back and look at our graph. Let's see where it crosses through the y-axis. Is there a place where we can find that exact value? In the equation, right? The number by itself. What is my y-intercept? 0.76. All right, now we want to know what it means. So we need to go back to the graph and find that coordinate. Okay, so if that is 0.76, then that coordinate is 0,0.76. All right, what is the 0 talking about? What is our 0 talking about?
Ingredient cost.
Ingredient cost. So how much do ingredients cost right now? $0. So no money is being spent on ingredients. So then what does our Y value represent? So if the ingredients cost 0, how much is it going to be sold for? 76 cents. All right, so when, or you can say the sales price is 0.76 when ingredient cost is 0. Yeah, I see y'all keep saying it's freezing up. I don't know why it's doing that. I keep stopping the share to see if it'll help, but one second. There. All right, there will be questions like number 3 and 4 on your homework. So you might want to just make you a little note. Like those are going to be homework questions, and number 4 and number 7 on the last problem, because it's going to give you an equation and it's going to ask you to interpret the slope and the y-intercept. And you're just going to put it in like a little sentence like this, based off of whatever that graph is talking about. Okay, so if it ever asks you to tell what it means in the situation, you have to know what your graph is talking about. Okay, so we're going to practice that a little bit more with these over here. We're not going to do all 4 of them. We're just going to look at these top 2 just for time purposes. It says here are several scatter plots. They give you the equation of the line of best fit right there for you. So let's look at this first one. It's talking about reaction time for our Y value and as you age. Okay, so there's the data about your reaction time in milliseconds and what happens as you get older. Okay, now on the next one, we've got the price in dollars and how it changes as the number of bananas that you have increases. Okay, y'all focus because y'all are about to have to talk about these. So if you turn the page, we have A and B, and basically it wants us to interpret the slope and interpret the y-intercept of each linear model. Now you can do it in the space provided, but I'm going to write my answers by the graph. So I'm going to do mine over here. Okay, so I'm going to do one of these with you, and then you're going to do the other one on your own, and then we'll be done. Okay, so which one do you want me to work with you, A or B?
The hardest one.
Okay, we're going to do A.
Okay.
All right, so first things first, we're going to interpret the slope. So I'm writing over here on the side of my book, slope. So in order to interpret it, we have to know what it is. What is my slope of this line?
Negative 9.25.
Negative 9.25. Okay, so let's remember, slope is the change of y over the change of x. So we always need to talk about our y-axis first. Okay, what is our y-axis talking about?
Reaction time.
The reaction time. So what's happening to the reaction time?
It's decreasing.
It's decreasing by how much?
9.
Okay, so let's start there. The reaction time is decreasing by 9.25. All right, and how quickly is it decreasing by 9.25? What's our x-axis talking about?
Years.
Okay, and so since it's just understood to be over 1, our slope, okay, unless it was a fraction, which it's not. So it's decreasing by 9.25 milliseconds. Sorry, I forgot to label it. Every what? Every 1 year. Now it's confusing because a lot of people think to go by how the graph is scaled, but you don't do that. That's just to organize your data. You go based on whatever your slope is. And if you're describing the slope, it's always out of 1, whatever. So the reaction time is decreasing by 9.25 milliseconds every 1 year. Okay, do we understand that that's what's happening? Does that make sense?
Yeah.
Doesn't it make sense as you get older, your reaction time is slower?
Yeah.
Okay, now let's look at the y-intercept, because now we are going to interpret that. Okay, what is my y-intercept? 400. Okay, so that is where it's going to be crossing the y-axis. So it's kind of going off here, but we know that that point is going to be 0, 400. That's where it's going to cross through my y-axis. Okay, so what is 400 when it's talking about the y value? What does that mean?
Milliseconds,
Okay,
0,
okay, so reaction time is 400 milliseconds when we are
0.
0.
Oh, babies are quick. I don't know. Their next usually.
Reaction time is 400 milliseconds when we are born. Based off of this data, based off this graph, who knows if that's actually true or if we would need more information to verify that. But yeah, so that is how you interpret the slope and the y-intercept. So now you're going to do the same thing for B. Okay, you're going to interpret that slope. I wrote, that says slope. All right, and you're going to interpret the y-intercept. I'm going to give y'all about 2-ish minutes. If y'all need more time, I'll add it. And then we will talk about it together and we will be done.
Well, just under the slope and y-intercept.
Just interpreting the slope and the y-intercept, just like we just did.
Oh.
Ready, go. Y'all have about a minute and a half left of this question. Mhm. Give me a thumbs up if you are finished. Fingers are cold. They actually are.
Hey, we should talk about quesadillas.
We'll have time to talk about that in like 3 minutes. We have to talk about it. We do.
Yes. Well, then do really well. Yeah.
Okay, here we go. Someone tell me, what is the slope of this line, Ava?
The slope is 0.44.
The slope is 0.44, and what does that mean, Ava?
The price in dollars increases by 0.44 every 1 minute. Is that what you want?
The price increases by 0.44 or 44 cents for every 1 banana. If you don't have something along those lines, then you need to fix it. Next, we have the y-intercept. What is the y-intercept for this data?
0.04.
0.04, so 0, 0.04 would be where it crosses through the y-axis. So what does that mean?
At 0 banana. No, at 0 money, you get it.
You had it right.
At 0 banana, it's 0.04.
Okay, so the price
No banana.
is 4 cents for no bananas. Okay, so why do we think that it already starts out at 4 cents even though you don't actually have a banana? That's what my class yesterday said. It could be like like what they have to make a profit, or it could be for the stuff that the sticker that they put on the banana. You never know.
I am too smart.
Okay, so that is all we are doing for lesson 4. Your homework has been posted.